right, so yesterday in 9:30 we learned about multiplying a monomial times a polynomial, and today we're going to talk about how do we multiply two polynomials. So if both of the things that we're multiplying have more than one term, how do we do that? I bet you'll find out that you already know how to do it. So let's start with a warm-up. So here's a shape, and we would like you to find the area of the shaded region. So this is review. Hopefully you have a pretty good understanding of what you would want to do. So pause your video and tackle that warm up. All right, so area, we know we're multiplying length times width when we're talking about rectangles, right? And if I want the shaded area, I would want to do the area of the big rectangle minus the area of the small rectangle, right? If I take the area of the big one, that's the whole thing, subtract out the white part, that'll give me just the shaded area, right? So the area of the big shape would be 12 meters times 10 meters. So 12 times 10 for the area of the big. And I want to subtract the area of the small. The area of the small would be 7 meters times 2 meters. 7 times 2 for the area of the small. All right, well, let's see. Area of the big, 12 times 10 is 120, minus 7 times 2 is 14. 120 minus 14 is 106. Now we're talking about area, so that would be meters squared. 106 meters squared. So notice that was multiplying, right? So in this one, we're only multiplying numbers, but we'll talk about what happens if I have a situation where I have polynomials as part of my side lengths. So that's coming up later. So this was a good intro to some things that we're going to talk about in a little bit. Before we get to that, though, let's just think about how would we multiply these. So if you see in the first one here, I now have a binomial, right? Two terms times a trinomial. That second one has three terms. So yesterday we learned about what would I do if I just had a monomial out front, right? Just one term. What did I do to multiply a monomial times a trinomial? Well, what I did was distribute. Well, you're going to do the same thing. It's just that I have more than one thing to distribute, right? When I see something like this where it says this binomial x plus 3 times the trinomial x to the third plus 4x squared minus x, it means I want to take every term in the binomial and multiply it by every term in the trinomial. And the way to make sure that you do that is to distribute, distribute, distribute. So I start with the first term x in my binomial and I multiply it to every term in my trinomial. So x times x to the third, x to the fourth. Then I have x times 4x squared, gives me 4x to the third, right? Because this is really x to the first. And then I have x times negative x would give me negative x squared. Now yesterday, that would be all we had to do. But today, we have a binomial, right? So now I have to take this 3 and I have to distribute it to everything. 3 times x to the third is 3x to the third. Notice I'm using that method where I line things up so I can combine my like terms a little bit easier. 3 times 4x squared would give me positive 12x squared. 3 times negative x is negative 3x. Now, you don't have to line it up like that if you don't want to. You could always just keep a big long line and then just pick out your like terms. That's perfectly fine as well. But now I want to combine anything that I can combine. X to the fourth, nothing I can combine with that one. 4x to the third plus 3x to the third, I get 7x to the third. Negative x squared plus 12x squared would be positive 11x squared. And then nothing I can combine with my negative 3x. And there's my final answer, right? So yesterday we distributed a lot. Well, today you just have to distribute more than once. Every term in the first polynomial gets multiplied by every term in the second polynomial. So in number 2 here, this time I have a trinomial times a binomial. You could rearrange the order if you wanted to, right? And then it would look exactly like number 1 if I put the binomial first, and then it would be the same process. But you don't even have to rearrange if you don't want to. I can take this first, right? I'm just going to have 3 things that I multiply, that I distribute into my binomial. So I could just start with the way it is. So I'm going to take this 3b squared, multiply it by 5b, give me 15b to the third. 3b squared times negative 6 will give me negative 18b squared. Then I'm going to take my next term, this negative 2b, and I'm going to multiply it by 5b. Gives me negative 10b squared. Negative 2b times negative 6, careful here, gives me positive 12b. I think I'm going to need a little more room. I'm just going to scooch this down a little bit. There we go. Okay, now I have one more term though. Now I have to do the positive 5. So 5 times 5b gives me 25b. 5 times negative 6 is negative 30. So now I have distributed all three of my terms from my trinomial into both terms of my binomial. So now I just combine anything that is the same. So let's see, 15b to the third, nothing to combine with. I can combine my negative 18b squared and my negative 10b squared to give negative 28b squared. I can combine my 12b and my 25b to give me 37b. Nothing I can combine with my negative 30. So there is my polynomial. And notice it is written in standard form. I should have mentioned that in the last one as well. Just making sure that we always write our answers in standard form. It just makes checking your answers a lot easier, grading your answers a lot easier. So just line them up in order, right? Okay, so that's it. Distribute, distribute, distribute. That's all we got to do. All right, let's take a look at this one now. So this is a binomial, right, times a binomial. We can do that. Same process, actually. You just take that every term in the first polynomial times every term in the second polynomial. So in this case, okay, 3x times 4x would give me 12x squared. I have 3x times negative 8 gives me negative 24x. Then I'm going to do 2 times 4x. Gives me positive 8x. Then I'm going to do 2 times negative 8. Gives me negative 16. Oops, I don't know why I changed colors on you there. Okay. And now just like before, oops. There we go. Now I'm just going to add up my like terms. 12x squared, nothing to combine with. Negative 24x plus 8x gives me negative 16x. And then the negative 16, nothing I can combine with. And there's my answer. Now, it just so happens that a binomial times a binomial is the most common way of multiplying polynomials. It just happens a lot. Binomials pop up more than any other type of polynomial in future math, in the real world, things like that. So because this happens so often, we actually give this process a special name. Now, all it is distribute, distribute, right? That's all it is. But we call it something special, and what we call it is FOIL. F-O-I-L, which is probably why I started switching my colors here. But what we're going to do is we're going to take this, and I'll line up the colors accordingly so that you kind of know where these letters are coming from, and I'll tell you what those letters stand for. So F stands for first terms. Notice the first things I multiplied when I distributed were 3x times 4x. Those are the first terms in both sets of parentheses, right? First. The next thing I multiplied when I distributed were the outside terms. I did the 3x times the negative 8, right? This one right here, that gave me the negative 24x. Change my color scheme, here we go. Those were the outsides. Notice they're the outsides of the, if you look at the whole problem, the first and the last, right? The outsides. All right, after that, I multiplied the insides. Oops. the 2 times the 4x. And the whole problem, those were the two inside terms. And then the last thing that I multiplied were the last terms, the 2 and the -8. And those were the last terms in each set of parentheses. First, outside, inside, last, FOIL. Now, if you notice, I did that when I just thought of it as distribute the first term to both, distribute the second term to both. It's the same exact thing. It's a fancy word for double distribute. But in a lot of your future math classes, your teachers are just going to probably refer to it as FOIL. It's just a quick way to reference distribute, 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 because distribute, say it over and over, is a hard thing to say. So we're going to call it FOIL. Now keep in mind, FOIL is for binomial times binomial only, right? If I look back at my last ones, I distributed more than 4 things. So the first one was 6. I guess the second one was 6 as well, right? But if you have more than just binomial times binomial, you're going to be distributing more than FOIL. So FOIL only works for binomial times a binomial, but it's just a fancy word for doing the same thing. So if I notice number 4 here, binomial times a binomial. So I could FOIL this one as well, or you can think of it as distributing, whatever works for you. So first would be 18y to the third, 6y squared times 3y. Outside would be 6y squared times 5, which would give me 30y squared. Inside would be -4 times 3y, which would give me -12y. Last would be -4 times 5, which is -20. Oh, in this one, no like terms. So I guess that's my final answer. So sometimes when you FOIL, you can combine some like terms. Sometimes when you FOIL, you can't, and that's okay. FOIL is just that double distribute process with a fancy name. All right, hopefully you're feeling pretty confident in multiplying polynomials. All it is distributing more than once, right? So remember that we discussed how we were going to do the shaded area. So this is kind of a situation where you might see some polynomials. The shaded area represents a deck around a swimming pool. So this part in the middle here is the swimming pool. All right, the deck extends 4 feet from the pool on all sides. Find the shaded area. So this doesn't have a lot of words, just to kind of keep it simplified, but think about this. Somebody says, I want to make a swimming pool. I want it to be 4 times as long as it is wide, x and 4x. That's a real world situation. That could absolutely happen, right? I don't know how wide I want it to be, but I want it to be 4 times as long so we could really swim a long distance. And then this deck around the outside, maybe that's like a patio, right? Cement, something you want to put around the whole edge so that you can jump in from wherever you want. And we want it to be the same all the way around, 4 feet in every direction. Now, I would need to know that area of that pool deck because I would have to pour the concrete, right? Or build it out of wood or whatever you're going to do. So this really is very much an absolute real world situation that a builder could encounter all the time, and just where you'd see polynomials. But it's just a shaded area problem. Think back to that warm-up, right? When I wanted to find this shaded area. Find the area of the big shape minus the area of the small shape, right? Well, that's what I'm going to do here. Find the area of the whole giant rectangle, subtract out the area of the little white one. That's the swimming pool. So I want area of the big minus area of the small. The tricky part is I need to know how long and how wide that big shape is. That we don't know yet. There's nothing written, right? I need to know what's this length. Well, I know inside here, right, from here to here, this is 4x. But I also need to go here and here. Oh, well, the left side is 4. And the right side is 4. And I want to go the whole thing. I need to add them up. 4 plus 4x plus 4. Or really, that'd be 4x plus 8, right? 4x for the middle, 4 on each side would give me 4x plus 8. All right, same thing with my height here, right? Or my width, however you want to think of it. Well, I know that from here to here, the pool part, this is x. But then I need to keep going. I need to do the top and I need to do the bottom. Oh, well, the top is 4 and the bottom is 4. So it'd be 4 plus x plus 4, or x plus 8. All right, now I know that my whole length of my big shape is 4x plus 8, and I need to multiply that by my whole width of my big shape, which is x plus 8. So there's the area of the big. Now I need to subtract the area of the small, the swimming pool, right? Well, the swimming pool was just 4x times x. All right, let's see. 4x plus 8 times x plus 8. Well, that's FOIL. First would give me 4x squared. Outsides would give me 32x. Insides would give me 8x. Lasts would give me 64. And then I need to subtract. Let's see, 4x times x is just 4x squared, right? X times x is x squared, 4x squared. Now I just combine any like terms that I might have. Notice I don't have any more parentheses, so I can combine anything I like. I see I have a 4x squared and a negative 4x squared. Those will cancel out. I have a 32x plus an 8x, which would give me 40x. Plus 64, can't combine it all. But there is the area of the deck, right? That's the shaded area. Area of the big minus area of the small would be 40x plus 64. So however wide I decide to make my swimming pool, 40 times that width plus 64 will be the area of my deck that I'm going to have to build. All right, so hopefully you can see that real world situation for you when you're going to have to multiply polynomials. But just remember, multiplying polynomials, distribute, right? Everything in the first polynomial by everything in the second polynomial. Combine those like terms, write your answers in standard form. If you're trying to find shaded area, take the area of the big one minus the area of the small one, and there you go.